Hello and welcome to Console Cowboys. So today we are going to install and attack readers between the reader and the controller to intercept the data off the lines. So that enables us to get a hold of card data when we can't get it another way and then get access to that facility by making cards. So we're going to run through doing that on a standard reader. We're going to take apart a panel reader. We're going to install these things, talk about practicing it before you get on site, so that way you're prepared when you actually have to use these. The hardware we're going to work with today is our ESPKey I have in here. We have a punch down tool to get the wires on the ESPKey. We have a set of cables and a 9-volt battery for initially configuring our ESPKey before we go in the field. And then we have a working card and a non-working card so that we can test the system and use our ESPKey, and then one we're going to configure to gain access if we were attacking it. We also have a screwdriver and a set of bits. You're always going to need these on site to open stuff up. And then we have our panel antenna. We're going to take a look at that. Usually you'll see those on like parking garages and such. And then we have our access control system with a reader and a door. So that's the hardware we're going to work with today. So let's take a look at the manual real quick. If you scroll down just a couple pages, you're going to get to a little diagram here of the device. Now we have 1, 2, 3, 4, 5 vampire clips. And starting on the second one here is the data 1 and the data 0, which are typically white and green. And that's going to be the data running over the wires that we're trying to capture. We also have the ground, which is going to be typically black. And then we have our VDC or our power, which is typically red. So those are the wires that you're going to clamp down on this. However, I will say a lot of the time, these wires are not the proper color. I've ripped readers off the wall, taken a look, and it was all kinds of rainbow of colors in there. So don't rely on the colors, but if you see only those colors, it likely is that. However, we're going to take a look at the back of the readers to determine how we can figure out which are the proper wires that we need to clamp down on here. So with that in mind, how do we configure this? Well, we're going to give it some power by just hooking up the ground and the power to the device and hooking up a 9-volt battery. You can buy one of these little cables from Red Team Tools that'll work. And I'll show you a picture of that here in a second. And then also, once you do that, you're going to see it power up. And we have a default SSID. So you're going to see ESP-key config, and it'll have some random number on there. That's just going to be a standard WPA key of access granted. And you're going to go to this URL. So I already have mine hooked up. You're going to see that on the side there. And if I click that and I go to the web page, this is what we are greeted with. We're going to go to Configure tab, and this is where we connect to it or have it connect to us and set up the configurations for that. So in order for it to connect to us is this part right here, Station SSID. Currently it's set as Bob as the default, and it has a blank password. So if you want it to connect to you, you need to configure this. But the main thing to pay attention here is this right here. It says Enable AP mode if station mode fails to connect. So if you don't configure this and it can't connect to you, and you uncheck this box and it can't launch the access point that we've just connected to in order to configure this, you have essentially bricked your device. So make sure that if you want it to connect to you, it's functioning properly before you uncheck this box. Now, what I would suggest is leave that box checked and configure this SSID with something like ATT Wi-Fi, just put here, or the name of a coffee shop next door, or just something like that a normal house in the neighborhood would have. And then have an AP password that is not going to be very crackable if somebody was running WPA cracking on it, so something nice and long. And then that way it brings up that AP. You can connect to it remotely from across the street, get a hold of your card data, open up the door, or make cards. You can also hide this AP if you want. Just be careful and make sure to write down the SSID and the password and put it in your Red Team notes for your configurations for all your hardware. That way, if you come back 6 months from now and pick up this device, you actually know what it's configured with. So what I would suggest, maybe take a screenshot of this, dump it into your OneNote or whatever you're using to keep your notes for all your Red Team operations. That way you don't lose it. So just a few gotchas there. Now, once you configure this, just hit submit. And then when it reboots, you should see the name of your new access point. Now, there was a little gotcha when it first loaded back up with ATT Wi-Fi. It actually was on the old one. I tried to connect to it. It failed. Then it brought this one up. So first time you do it, it might glitch a little bit, but then you should be good. So now that that is configured, let's take a look at how to install it, what these things look like, and also talk about a lot of other issues you need to think about. So taking a look at our devices that we may attack, there are a few things to think about. One, we need to have the data 1 and the data 0 lines connected to, and then we also need to have the power and the ground. We need to get a hold of those wires. So here we have a typical reader that you might see on the outside of a wall, and we have a typical large panel reader you might see outside a gate, or you might see it on a parking garage. You can attack either one of these in the same way, but you open them a little bit differently. So this one, on a normal reader, usually you'll see a screw at the bottom when you look underneath. Like this one is a number 6 security screw, I believe. It might be a Phillips head. So you're always gonna have a set of bits with you to handle those situations. Now, once you unscrew that, you can pull it off the wall, and then you're gonna see the wires that you're gonna connect the ESPKey to. So we have our white, green, red, and black. Now they may be random colors. If they are, you can take a look. If it has a diagram, it might say data 1 is this one, data 0 is this one, ground, and power. But if it's not labeled, you can look up, this is an I-class reader, which one should be plugged into each, and then you know where to plug in your ESPKey on which wire. Now, there's other readers, such as the Signal reader. Once you unscrew that, it kind of opens up weird like this, and then you can pull it off the wall, and you might have like a little thing with the wires all connected to it, like a little conduit thing. You can keep pulling until you eventually somewhere hit the pigtail of wires, which then you can connect to your ESPKey in there. And that's typically what it's going to be like as well. You're going to see this guy, and then it'll open up to the individual wires, and hopefully they're the right color. Now, next up, we have our panel antenna. That's going to be one screw right here, and then a rubber seal. So you're probably going to have to stick something like a flathead screwdriver under between here and then pry it up. Otherwise, it might be hard to get off. And then inside here, you're going to see something similar. So we have our power and our ground right here. And then we have our 2 data lines here, and these are nicely labeled for us right here. So we would be able to tell which one's which for our ESPKey by the color and also by the label here. If the colors were different, we can look at the labeling here and figure out, okay, this bottom one in here is DC, so that's this one, and then our ground, and then if tamper's hooked up, as well as our data lines up here. Now, another thing you could do is, this is a standard HID reader, just looking at the outside case here. So you can look that up online. You should be able to find a YouTube video or a diagram showing you which wire is which, and then you hook up your ESPKey accordingly. So those are the wires and how to take them off the wall. Now let's take a look at installing this thing. So we're going to install this now. We have our ESPKey here. We have our wires out. And we have this bit here for our screwdriver, which allows us to punch the wires down onto vampire clips. Now, before you do this, though, I will tell you, go buy a package of wires from a hobbyist kit and practice punching those wires down onto these vampire clips. So when you get in the field, you make sure you know how it feels when they're actually punched in correctly. So when you're doing it in the middle of the night and you have a short amount of time, you make sure that you do it properly. So just something to think about. Now, we have our wiring diagram up on the screen. You'll see that we start with our white wire on top here, and we've verified inside there that we are using the proper colors based on the diagram. So we punch this in here like this. And then next up we have our green wire. So we'll punch the green wire in here like this. And then we have our black wire, which is our ground. So we did our 2 data. Now we're going to do our ground. And And then last but not least, we're going to do power. And the reason we're doing power last is we don't want to short anything out. We want to make sure everything's hooked up first. So we are going to punch that in here now. When that power wire is punched down, you should see the light turn on and you're good to go. However, note when I was punching it down, I was going at a weird angle and moving back and forth. Don't do that. I was just working around equipment. So if you connect to your ESPKey after you install it, you'll get back to this web page again. And I scanned a couple cards when it started up. And we have the data right here. And we see our hex value, the bits, and the Weigand bit stream, which would be the data because it's Weigand protocol. And if we click one of these, you'll see, okay, here's the raw hex. And then we have our raw binary down here, which it deobfuscates for us up here of a bit length of 26, possible card number of 16180, and a facility code of 42. Now we could hit transmit and open up that door, or we could change these values in here, maybe log in as 181 if we wanted, and kind of brute force through if like maybe that person's card failed to work, or maybe this is on a data center door and that card didn't work, but another one might. We could kind of go through that possibly. But what we really want to do is we want to create our own card if possible. But this is where we get into the discussion of protocols and whatnot. And I'll get into downgrade attacks in another video. But essentially, if they scanned a card that we can clone, such as this is iClass, which is a broken card, they figured out the encryption on it. If they're using that, we can create our own card from this data. And that's the best case scenario, because then we have a legitimate card to scan and nobody's really going to look very closely at us if we are dressed properly, we scan a badge and it works. And to go that extra mile, we can find the look and feel of the badge online. We can create our own sticker, stick that on there. I'll create a video for how to do that. And then we're able to just walk in that facility with a badge that looks correct, a badge that works, and it's downgradable. Now, the beauty of this ESPKey is, though, if we were not able to clone this card, but we were able to install this and they're not encrypting the data, they're using old Weigand protocol data, then we can still open up this door and at least get inside. So if that was the main barrier of entry, once we're going to get in the facility, we can walk anywhere we want. This would at least get us inside, and then we can get our mission done and we can leave. But it's better to have a card. So let's take this data and let's create a card. So what I'm going to do is I'm going to hop into, we're going to copy this. We have a facility code of 42, and we're going to hop into Kali, and I have a Proxmark connected, and we can put that data in here, but actually I think there's a better way to do that. So let me exit out of here, and we're going to use our doppelganger assistant, because that's a better way to do it. I've done that in other videos before. So here we have doppelganger assistant. We're going to do iClass, and we want this, I think it was 16180 with a facility code of 42. And I'm going to place my card on here, but before I do that, I'm going to show you that it's not actually working. So let's do that. So we have our ESPKey running on here, and we have a working card here and a latch. If I scan this, you'll hear that click, and this latch will open up. But if I take another card, which is not configured, you'll hear a beep, but there was no click, and this latch does not open up. So we want to take this card, and we want to take the data from that ESPKey, and we're going to put it onto our Proxmark and configure that so that this one will open up the door. So now I'm going to hit enter on this, and it should create an iClass card for us with that card, and then that card should work on the door. Okay, perfect. Let's give that a shot here. Taking my card here, we're going to, and I just heard the latch go, so we are good to go. So that works successfully. So we have a working card, we can walk in the facility, but let's talk about the important stuff now, like why did this attack work, when we would use this attack over other attacks, and implications around that. So first off, why does this attack work? Well, it works because where you scan the card on the reader and the controller inside, that green and that white wire that connect those are sending data unencrypted over that wire. So therefore, we are able to grab the unencrypted data with the device that we put on there. Now, this is pretty typical in most organizations. They don't turn on the encryption. So this attack will work in a lot of scenarios. And once we get a hold of that data, we're able to create the card like we just did if the reader supports a broken protocol such as I-class or lower frequency cards that we can clone onto another card. Now, if we can't clone those, we could hit the little button you saw that just retransmits that data, and then it'll open up the door anyway. So it's great for those types of scenarios. But there are other ways to break in. We could use a long-range reader, or we could use a fake reader. Now, a long-range reader is great if users are displaying their badges or have their badges on them, and we can get a hold of that data. But there are risks there. We have to walk up to a user. We have to not be suspicious. They have to have a card that is supported on the reader again. We might get that data from them, but we might not be able to write that to a card that the reader supports, in which case the ESPKey would be better. Now, the other option might be that fake reader on the door. But again, if they're using cards that we can't clone, we might get a hold of the data, but we might not be able to clone a card that works on the door, in which case we can retransmit with the ESPKey. So there's other things too. Let's say that they are using clonable cards, but they don't wear their badges outside the facility, and where the readers are being monitored by security all day long, but at night we can walk up, unscrew that reader, install an ESPKey, and get a hold of the data in the morning just connecting to it remotely over Wi-Fi. Now we can create that card and walk in. Maybe they are using clonable cards, but the security is stopping us from doing it during the day. So these are the things to think about why you should use one tack over the other, right? It might be a really good idea to just install the ESPKey at night and handle it that way. But if they're using clonable cards and you're seeing employees walk all over the place with badges, that might be a much better option, because then we get into another problem with the ESPKey. It does technically damage the equipment of the client in that the wires, once you pull those off of the vampire clips, those are going to have slices into the wires, and you're going to want to use electrical tape on those as a temporary fix and let the client know you need to replace those wires so that nothing shorts out. Or you could accidentally, break a wire while you're doing it, and then that makes things inaccessible. So what I would suggest is, within your rules of engagement and within your SOW to the client, that it specifically states you will be using these types of attacks, and explain what they are. We're going to put a device on there that has vampire clips that could damage the wires, and you put that right into your rules of engagement, as well as once you've assessed the facility and you've determined that the best avenue of attack is this ESPKey, you explicitly ask your client, is it okay for me to install this? We have it in our rules of engagement, but I want to explain to you the implications of this. This could damage stuff, it could cause issues, and you're going to need to replace the wires. Would you like me to proceed with this attack? A lot of clients are just going to let you go through because you're going to explain to them, it's just a little bit of damaged wires. I'm going to electrical tape it. You just get an electrician out here real quick to fix it. Other clients might not want you to mess with it because you might screw up access into a facility, and it might just be a very, very bad day. So these are just things to think about when you're doing professional penetration testing on physical targets. So if you learned anything from this video, share it out with other people, subscribe and like the channel, and I will catch you later. I hope this was very informative for you and you learned something good today.